Hey calculus students, I just wanted to make a quick video to go over the last problem from the practice quiz because there were a few of you guys that missed that one. So if you're getting this email, you missed that problem in the practice quiz. But hopefully from this you'll know how to do it. All right, so the function was y equals 5 plus 2 root x, and you were asked to find the equation of the tangent line at the point 9, 11. All right, so equation, tangent line, abbreviated, at 9, 11. All right. So first of all, we have to find the derivative, all right, as we have to do every time with this unit, because the derivative represents the slope or the rate of change at any point on this function. All right. So to find the equation of the tangent line, the equation of a line, y equals mx plus b, involves m, the slope. So we first need to find the slope by finding the derivative. The derivative of 5, just a constant, is 0. Right? The derivative of any constant, any number, is 0. So this drops out. Now 2 root x, we can think about that as 2x to the 1/2 power. So using the power rule, we bring the 1/2 in front. 1/2 times 2 is 1. And then we reduce the exponent by 1. So the exponent was 1/2. 1/2 minus 1 is negative 1/2. All right? So the derivative function is just y prime equals x to the negative 1/2 power, right? Now, another way we could write that, of course, would be 1 over x to the 1/2, which is 1 over root x. And I think it's going to be easier for you guys to, even though I told you when we're writing derivative equations, you don't need to get rid of the negative exponent. I would accept this. With this problem, because we have to plug in 9 for x to find the slope, I think it's going to be a better idea to write this as a fraction and using radicals, all right? So now we evaluate the derivative at an x value of 9. 1 over root 9 is 1/3, all right? So that means the slope of this tangent line we're going to find is 1/3, all right? And the graph has to go through this point, all right? So we now have to consider the point-slope form of a linear equation. We know the slope of our line is 1/3, and we know the solution of 9 and 11. So we have this equation set up here. And all we have to do is solve this for y. So now it's like algebra 1, 1/3 x, 1/3 times negative 9 is negative 3, plus 11 is plus 8. That's our answer. All right. If we wanted to, we could check a graph, very quickly. 5 plus 2 root x, that's just going to be the square root function made like twice as steep and then shifted up 5. So it'll look something like this. All right? The point 9, 11, say that's like around here. So the tangent line here is that guy that we're finding. Right? That's the tangent line. So that line's equation happens to be this. I just want to give you guys a visual of what we just did. All right? So hopefully that clears up some issues. I know some of you guys were a little bit confused on this problem. You got here with the derivative, but then you didn't know what to do. But finding the equation of the tangent line, you have to find the slope at that point, the rate of change at that point 9, 11, which we found was 1/3. And then we have to use point-slope form to get the equation. All right? Hopefully this was helpful. See you all on Friday.